Kubernetes security learning series point of view. 12th topic is Open Policy Agent. Short form is OPA. So I am in a training.linuxfoundation.org, and if you scroll down the CKS syllabus, minimize microservice vulnerability, set up appropriate OS level security domain, example using PSP OPA. So today's topic is OPA. In the previous topic we have seen about the PSP and with the demo, and if anybody have not seen, please go and look at. So today we'll try to understand OPA, which is nothing but Open Policy Agent, right? So Open Policy Agent, if you go to the Google and just search OPA, right, Open Policy Agent, right? So here we need to understand OPA with respect to Kubernetes, right? So let's try to understand. So before trying to understand the OPA, let's try to understand how the API call will work. So as usual, we will take a one deployment YAML file where it has some deployment, one pod, one service, one config map, one secret, blah blah blah, right? All your application is you are deploying. So first what happens, it will take a existing user and first authentication phase will happen, then authorization phase will happen, then after that admission control will come into the picture. So means after that, who is the person, whether legitimate user or not, then authorization, he is whether he has access rights. After that, these two are the security checks, right? Then third check is admission control. Before storing into the etcd key value database, admission controls comes into the picture, and which will checks whether required things are there or not. So we will try to understand admission control. Maybe you can wonder why we are trying to understand when the topic is OPA. Yes, OPA is built with admission control inbuilt. So just we need to understand. So let's quickly look at that. If you look at the admission control, right, there is a previous video I have created on the admission controllers. So please have a look at that video as well. You will get a good idea. So basically, if you look at the admission controllers in the Kubernetes, there are so many admission controllers which will be comes into the picture. So out of this admission controllers, there are a built-in admission controller. Some of the controllers are dynamic. What that it means? Built-in means always pull images. This red color which I marked are the dynamic admission controller. What are the built-in? Rest of the things are. So what do you mean by built-in? Means these built-in admission controllers are developed by the Kubernetes. But whereas dynamic admission controller, where you can develop a webhook, you can attach a hook to this particular controller so that the logic will work accordingly as like you want, as simple as that. So let's go further. So here just note down image policy webhook. So all the dynamic admission controllers are ending with a webhook. That means you can attach a webhook, right? So whenever you apply some deployment, right, during the admission controller phase, first of all, system will check default admission controllers whether applicable or not. If not, it will check mutating and validating. Mutating and validating, what it will does, is there any webhook? If you define, it will check on this YAML file whether is there any modifications are required to this or not, or is there any validations to be thrown in this YAML file or not. So these are the two admission controllers. So if you look at, right, dynamic admission controllers, right, in the previous slide I said, right, these admission controllers basically image policy webhook, mutating and validating. Mutating, what it will does, whenever you apply a deployment, it will modifies. If you define this webhook, if you define this webhook, it will validate whether it's correct or not, because you create just YAML file and deploy. So who will verify? This guy will verify, dynamic admission controller, right? So as simple as that. And if you want any more information, please go and look at my admission controller video. Now the next is we will try to understand the admission controller phase. how the admission controller. So basically the series of admission controller events, when it's triggered by the API handler, after the authorization, first mutating will comes into the picture, and mutating will check is there any webhook available, and that hook will apply. Then after that, at the last, a validating admission controller. How this will work? This is a dynamic, so it will look for a webhook. Whatever the webhook you define, that hook will execute and then store into the etcd. If it is pass, so it should pass these two gates, then only it will store. Means store in the sense this object will be created in the actual cluster. Then next, what is a mutating webhook configuration? So in the mutating, what you do is simply you will create a one webhook. Webhook is what? It's a one server. Server means nothing but it's a service, Kubernetes service. So this is a webhook, and whenever somebody apply any pod, I always run this guy. So that's what the mutating. What it will does, whenever anybody trying to create a pod, go and execute this particular web server. This maybe you can ask whether I can use only service or anything. You can use anything, not only the service. So that's what the, so right, so you can just specify so that it will execute, and what this will have your own custom logic. Then second, validating webhook configuration. So here basically if you look at this example, whenever you create this validating webhook configuration, what it's saying is whenever you create or update of deployments and replica sets in this particular API groups, apply a validation. So if you look at the another example, whenever you try to create any API or any namespace, anything, the label must be environment as a prod or staging. Without these two labels, it will fail. So in this way, it will validate. If it is not there, it will fail. That's how it will does. So now, open policy agent. So basically, what exactly the open policy agent? So if you look at the OPA, right? I just clicked on the OPA, open policy agent, right? And documentation. OPA, right? Open source general purpose engine for policy enforcement. So basically, let's try to understand. So OPA is open policy agent. It's open source and it's a general purpose. What it will does? Policy enforcement. Policy means some certain rules, some certain policies. It will enforce. Make sure it will be done. Make sure it will be followed. That's what the enforcement. Using what? High level declarative language. What is a high level declarative language? Whatever we do in the YAML file, that's called a high level declarative language. So OPA, what it is for microservices, Kubernetes, CI/CD pipeline, API gateway, cloud native, any cloud native application, cloud native service, you can apply this open policy agent. But we are talking with respect to the Kubernetes, right? So for us, we need to understand, for Kubernetes point of view, there is a called OPA Gatekeeper, right? What is this API Gatekeeper will do? It will does the same. It will enforce the custom policies. Means you can set some policies on what? On Kubernetes objects, which is at the time of a creation. So that means I will try to create a one pod, and if you set some custom policies before creating, it will apply. If it is not satisfied, what happen? It will throw error. So maybe you can ask what kind of a policies. Say for example, whenever I try to deploy a YAML file, all images must be approved repositories. That's a one criteria, right? Say for example, I will go to the Kubernetes documentation, right? Say pod. I just simply create a pod, right? Say for example, if you look at this pod definition file, right? This image nginx.1.42, right? So here all images, say for example, tomorrow somebody will specify xyz.com and nginx/1.4.2, which is not a correct one, which is something is a different nginx image, where is a hacked one, for example. So if you wanted to check all images must be approved, or maybe all ingress host name must be globally unique, all pods must have a resource limit. So every pod you go and create, right, that pod should have a some resource limit like a CPU and memory and all, right? So and all namespaces must have a some label of point of contact. Say for example here I'm in a 2 node cluster, say kubectl get namespace, right? All this. So kubectl create namespace, I will create a dev, right? kubectl describe namespace dev. And is there any label? By default this label is applied. What is kubernetes.io metadata name equal to dev. But if I wanted to apply any namespace should have a some point of contact, something like author equal to say GVR, or some author equal to Steve, something like that. So you can enforce by using this OPA gatekeeper. I hope you understand, right? Now, so for the documentation point of view, in the CKS preparation guide number 4, just scroll down, right, OPA, and there is a chapter OPA and everything is here, whatever I am going to demonstrate today, right? And there is a documentation as well, right? You can just click on this documentation, right? So this is a documentation about the OPA gatekeeper, and all the information is here, right? Go back to the slide, right? Current version is basically 3.0 OPA gatekeeper for Kubernetes. Maybe you can ask, where is a gatekeeper 1.0, 2.0? So basically if you refer the documentation, gatekeeper 1.0, 2.0 are implemented earlier by using a different concept called a sidecar, and which is totally, it's a different concept, and it was donated by the Microsoft. But currently the latest version is gatekeeper 3.0, which is implemented by using a admission controller, which I initially told about the what is admission controller and all. And this OPA consent framework is everything is also created to enforce by using a CRDs, which is custom resource definition. And this is a project collaboration between Google, Microsoft, Red Hat and Straya. So these companies are created and now it's open source, right? This is the background about the what is a gatekeeper. So what exactly this gatekeeper will does, right? Basically gatekeeper 3.0 is implemented by using an admission controller, which initially I talked. Then it is by using a declarative way you can achieve custom policies, means you can enforce a custom policies of this kind of, means what kind of a thingy you can validate, you can mutate, or you can control, you can audit and all, you can verify. So basically if you are working in a one company and you wanted to enforce everybody, so if it is a 50 developer working on the Kubernetes cluster and you wanted to tell them to follow the certain rules while creating a pods and definitions, other definition, then if somebody doesn't follow, what you will do? You will go and tell. But here gatekeeper is basically, if you create a open policy agent gatekeeper as a administrator, basically it will throw errors if somebody doesn't follow, right? As I said, say example pod, right? Say Kubernetes documentation, and I go to the pod. Just now we went, say this is a declarative, right? Declarative means I want the name of the container, this I want the, right? Here I have not specified any label. If you create a one gatekeeper rule, that is every pod must have some label. If it is label missing, then definitely it will throw the error. That's kind of a policies you can enforce. Unless I don't add here, then it will keep on throwing error. That's what but here admission controller and declared. So then how this will work? Basically it is gatekeeper is implemented by using a policy templates. policy template which internally uses a Rego is a language, and by using a CRD is nothing but a custom resource definition. These all internally used for this gatekeeper, but you need not to know much about the Rego and all CRDs and all. But if you want to know CRD, there is a video I created, just go and please refer. Now the next slide. Okay, Gatekeeper 3.0, right, where we have seen in the documentation, right? This 3.0 has what are the features? One is a validating admission controller, right? Earlier in the previous slide, I have explained about the validating admission controller, and you can create a policies and constraints. Of course, our open policy agent, OPA, is nothing but policy and governance you are doing for the Kubernetes, right? So that whatever the policies and constraints you can define by using this 3.0, and you can audit as well. Say I have a 50 namespaces, right? kubectl get namespaces. Here I have 1 2 3 6, but I have 50 namespaces. I wanted to make sure some audit happening. Then you can just check audit, means how many places errors are going on and all, right? And you can replicate the data. That means, say in the dev namespace I have such labels, and I wanted to replicate to the UAT namespace, you can achieve. That's what and this architecture diagram is this, which is available in the official documentation right here. Right here, basically what it does is, OPA is a gatekeeper which is installed in the Kubernetes cluster, and internally it will have an admission controller, and also internally it will have a webhook, and internally it will have a CRDs, which is custom resource definition, and that will look for the, you will be defining in a declarative way that my pod should have some label, or my config map should have some label, my deployment have some label. So this agent is basically take care of whatever you define, and ultimately it will achieve security for you. That's what the overall, right? So, and how you implement a OPA, right? In my cluster, say this is my cluster, how I wanted to basically install. First, I need to install a gatekeeper, first, number one. Number two is, I have to create a constraint template, right? Which is, it has a Rego. I will explain what exactly this. Third one is a constraint CRD. So after installation, you will be creating a template and constraint. Then after that, create a deployment and test it. Test what is this constraint. This constraint, say example, some label I need, something like that, and observe the enforcement. So once you deploy, then you can test whether it's working or not, this gatekeeper, right? This is a simple process. Now, how this constraint, the first one, constraint template, how this template looks like, this is a template, and in fact, you go to this documentation, scroll down, here is the example, I'm trying to explain this. So here, basically, if you look at this, right, under the spec CRD, which is a custom resource definition, here kind is K8s required label. This is a CRD which is going to be created with this template. And what is the validation is here, string, right? And target, what is the target we are doing here? We are here Rego is basically a language to achieve this OPA. In the Rego language, so all this logic is defined to check whether my Kubernetes namespaces required a label or not. Kubernetes required a label, it's a generic one, right? Then this is a template you created. Once you create a template, you need to create a constraint, right? As we seen in this, right? Second constraint. So template, then after that constraint, then constraint. How you create a constraint? K8s required labels. Where is this K8s required labels? Which is this guy, right? So this K8s, and this name is I have given. You can give any name. Then what you are doing is, you are creating a constraint that my namespace should have a label as a HR. So must have a label means what happened? If I create a namespace without a HR label, it will fail. That's what it means. Then let's look at the different example. If I specify my namespace should have a finance label, then this is a label. What is a label? Is enforcing here finance. So this is an example. Now third, audit, right? Also we have seen the audit as well, right? What exactly this audit? Say for example, you have created namespaces must have a HR label. So I have executed, but in my team, developers are created. There are many times developers are executed, try to, and then I wanted to see what happened. Here enforced, yes, it's enforced, and you can check the audit. That's what it's auditing, right? How many places happened, and in the namespace, kube system, kube public, and gatekeeper system. So these are the namespaces, and these are the errors are thrown. That's what the audit, right? And replication. So here what you are doing, you are replicating basically between the namespace and pod. Same, what you are doing is syncing. So replication you are doing of this gatekeeper rules, right? I hope you understand. So this is the word that you are replicating, means instead of creating again and again, you are replicating, right? Now how you implement a gatekeeper? Yeah, already we have seen this 4 steps process, right? Now let's go and install. So now I will go to the documentation page, right? And open policy agent gatekeeper. I just clicked on this first link, then I go here, right? This is a GitHub page where installation instructions, right? Here installation instruction, I clicked here, it's open policy agent github.io. This is a page for gatekeeper, right? So as a installation instruction point of view, first they are asking RBAC permission and make sure you have a cluster admin permission. So if I go to the my Kubernetes cluster and kubectl config current context, and I am as a Kubernetes admin, so no problem. kubectl config view, if I look at my kube config and I am as a Kubernetes admin, so I have a full admin rights, no problem on that. The next step is what? Next step is this is skip, then installation. Now currently is a 3.7 release, just try to remember, copy and then go here and kubectl apply, simply just copy paste it, that's it, right? Now everything is created, right? All good. So all created. Now kubectl get namespace, let's see, is there any namespaces created? No. So yeah, there is a gatekeeper system, so kubectl get all -n, just I wanted to see what happened. So here, right? So basically gatekeeper audit, gatekeeper controller manager is created, and there is a gatekeeper webhook service and gatekeeper audit controller manager. What is this controller manager? It's a admission controller, one of the admission controller, and it's a has a webhook. So if you go dig into this one, you will be able to understand what is that. Now so let's wait until this pods will create. Yeah, right. Then after that, once you deploy, then you can just go and do your work. So you can deploy by using a Helm as well, and if you want to uninstall, just simply delete it, that's it. Then let's go to the example. So example point of view, just click on the next example. So I'm just following this documentation, and right, so I'm just how to use a gatekeeper, right? Perfect. So basically here I wanted to, let's see if the pods are created, and yes, all good. Let's see again, just with a fresh look, all are running and my everything is good, right? So now perfect. Here let's try to understand this example. Now as we see in the slides, right? First installation completed. Second is a create a constraint template. So what exactly this constraint template? That constraint template will have some rules to, sorry. So basically constraint template, basically it has some rules to define, right? So basically we will see I will copy from here itself, right? So I'll copy this particular constraint template, and or else instead of copying, what I will do, I'll just copy this particular URL. It's easy, right? So, and if I go here, right, kubectl apply -f, and right, and if you wanted to really see what exactly it means, go to the browser and just paste it, this YAML file, and which is the same as what they in the given in the example, right? Consent template, right? And right, as like we see, right, here is a kind is a required label and OpenAPI VPS schema, and this is a Rego language logic, so it's no need not to worry. So I'm just applying, right? So oops, sorry, it's applied 2 times, my bad. It's copy paste multiple times, right? Now it's created. So basically what it's created the custom resource definition, right? How to check that, what is installed? So kubectl API resources grep for CRD, right? See, custom resource definition. So if you look at the kubectl API resources and all, right, and I entered here, what is the this is created key items required labels, right? Yeah, see, constraints templates, which is a one of the resource is created. This is a resource name, right? I am asking for a kubectl API resources, so this is a custom resource which is not came with the by default Kubernetes cluster, right? That's what the consent template, and it doesn't have any shortcut, right? By using that, it's installed this. Now first step is completed, right? Now cool. And then what was the I have created this is a consent template, right? So how to check that, right? So kubectl get constraint templates, right? Yes, there is a one consent template which, so let me do it. Kubectl get consent template, right? Just now we have done this step, which is nothing but this guy consent template. So, and if I try to kubectl describe, and it's a very big, I'll just copy paste, and then constraint template space, this is a consent template name, right? So what exactly this consent template is saying, all this logic is here. So right, this is the one, and it has a mutating webhook and all, it's there. Whatever the admission controller I said initially, it has internally. So far we created consent template. Now the next step is constraint we need to create. So here, if you scroll down, constraint template and constraint, just easy to remember. Here, this constraint template is what it is saying is, there is a constraint is creating which is a type of this kind of type, and namespaces must have a GK. This is a GK is nothing but a gatekeeper, a label for the namespace. That's what the constraint. So what I will do is, I will just try to create my own constraint by taking this. So what I will do is, I'll go to the console, vi constraint .yaml, and I will open and I will paste it. So what I will do is, so I will create a one constraint which is, instead of namespace, I will create a deployment must have a environment label. That's what I will choose. So what is the API group for a deployment? It's a apps. So I will apps apps. And what is the kind I am targeting? Not on the namespace, because I am creating a my own constraint, not on this one, right? Right. So here say deployment, so capital D must be then, and what is the label I want? Every deployment must have an environment. So I will enforce the people to env, right? So right, and then I'll just simply close. And what I will do is kubectl apply -f, and I will try to install this constraint. So now it's created. What exactly this is created? This is a, here if you look at this cat constraint, right, .yaml, here what is the kind here? K8 is required label. This is a custom resource definition. kubectl get CRD, right? See, this is the one, right? So this is the custom resource definition I created. So now if you go back to my slide, constraint template I created, constraint is created. Now the third step is I have to create a deployment and see. So what I will do is I will go to the Kubernetes documentation and search for the deployment, and I got this particular deployment YAML, simple one. I'll just copy here and go vi deployment.yaml, and then I'll just paste it here. So what I will do is I will keep as it is deployment, and here note down, I'll just simply as it is I will install. So right, what is the my constraint is talking, whenever you deploy whenever do you do any deployment, it must have a environment label. So let's do, should I try to apply now? So ctl apply f and deployment.yaml, right? Now see what it is doing, it's failing, it's throwing me the error. What kind of error is throwing? Error from the server, deployment must have environment, right? You must provide a label environment. Error when creating this deployment YAML, admission webhook, validating gatekeeper.sh, denied the request. So first of all, deploy must have environment. What is this deploy must have environment? This is constraint, and what it has environment label, error while creating, and admission webhook validating.gatekeeper.sh. Where is that? You go to the documentation and in the constraint template, what is the target you are created here in the Rego language? admission.k8h.gatekeeper.sh. What exactly? It's throwing a one violation error. That's what this violation error, right? Denies the. And how to solve this problem? Go to the vi.deployment YAML file, right? And now we will try to add a label and it should work. So here under metadata, under label, let it be that and env colon. So it's a dev environment. Let's like say, let's take a demo, right? And I don't want replicas 3, just one is enough, right? Now kubectl apply -f deployment. Now what should happen? It's created. Now the deployment is created. Now next thing is we will verify. How to verify that? So I'm going to say kubectl get deployment, right? And yes, it's created. kubectl get pod, yes, it's created, right? Successfully created. And how do I see? Because where I have applied my constraint, which is nothing but this is the constraint I applied, right? What is my constraint? Let's recap. Cat constraint, right? My constraint is on the deployment. If you do any deployment, it should have a label, right? And here kubectl get pod -- show label. Pod has a normal label, but I have applied on the deployment. So kubectl, instead of pod, I will do the deployment. What happened? See, environment equal to demo. So if I specify without environment demo, my deployment was throwed me an error. The similarly, namespace must have a GK. Say I'll just try to install this, right? Just simply, it's a very quick another demo. So right, clear. kubectl, I'll just try to paste this right now. What is this particular? Any namespace you create, it should have a gatekeeper label. So let's create a kubectl create namespace, say UAT. See, it's showing me the error UAT or anything, any name you give. Error from server, you must provide a label gatekeeper admission webhook blah blah blah. So it will throw error definitely, right? So if I specify, say kubectl create a namespace UAT, right, hyphen dry run equal to client hyphen o YAML and redirect to ns.yaml and my vi ns.yaml. I'll open that, right? And what is a label gatekeeper, right? So here under metadata after the name, right, you labels labels, and then after that gatekeeper is a, and then say gvr, just like that, right? So kubectl apply -f ns.yaml, right? Now kubectl get namespace, right, UAT is there, and kubectl get namespace -, show label. Yes, my UAT has a. So here basically with this demo what we have done is in a very simple fashion for OPA point of view, create a constraint template constraint on the whatever the your resource, that's it, and make sure your deployment specific, not only deployment, anything on anything you can configure such kind of a rules, but only the thing is you need to know this rego. So that's what, and then maybe you can explore this documentation and Kubernetes documentation, what they are saying and all. So yeah, and I'm just trying to explain the what exactly it is and how can we leverage this. And thank you. I hope you guys like my video, and let me know your feedback in the comments. Thank you.